Qualia Research Institute is working on the hypothesis that conscious mind states consist of topologically segmented electromagnetic energy states which are produced by the electrochemical activity of brain neurons. Experiences of pleasure and pain are examples of mind state properties on the valence axis, which forms a spectrum going from neutral towards increasingly negative experiences in one direction and towards increasingly positive experiences in the other direction. It is the fact that many degrees of positive and negative valence can meld in the same moment of experience, which makes it possible for us to have generally intelligent common sense decision-making where we choose the best option among several conflicting alternatives. But why does the valence scale appear to be nonlinear? In everyday life, the range of valences is often limited and seems approximately linear. But if you happened to be stung by a bullet ant or got reunited with your long-lost child, you'd be surprised by how incredibly intense some of the more uncommon valence states are, compared to what you would have guessed based on only ordinary everyday life. The answer might be found in drawing a parallel with the much smaller topologically segmented electromagnetic energy states better known as atoms. Atoms can interconnect into solids, liquids, or gases. How strongly atoms interconnect turns out to also be on a nonlinear scale. For solids, the strength with which the atoms are held together is reflected in the hardness. For gases, the strength with which the atoms are negatively held together is reflected in the pressure. Liquids are neutral in that they have essentially no hardness and exert very little pressure in weightless conditions, although external forces can readily be transmitted through them. Does the brain produce some mind states which are like liquids, some which are like solids, and some which are like gases? The gas-like states could put pressure on the liquid-like ones to make them feel negative. With positive valence, the liquid-like ones may crystallize into different topological geometries with several levels of hardness. The whole process being self-organizingly orchestrated by an interplay of neuromodulatory molecule concentrations, sensory input, and the memory information stored in synaptic weights.